All right, guys. My question is, this is a very important question. How can you find a language is regular? How can you find? How can you find a language is regular?
So we need to know if language is finite or not first. If it is finite, sir.
Yeah. If the language is finite, what is the conclusion?
Then it is regular.
It is regular. Why?
Because sir, we can use a finite automata to represent that language.
How?
We can draw the finite automata.
Your answer is correct, but you cannot express yourself.
We can add all the strings. Suppose.
Not say add, not
Sorry,
say
I mean
add.
union.
Union. So let's something like this. A is AA, AB, AAA, and ABA. Something like this. So what can we do? We can come up with
We
for
can do
this
union
one.
of all these
Yes,
strings.
the most naive way. This one would be finite automata 1. This one is finite automata 2. This one is finite automata 3. This one is finite automata 4. And as it is a string, definitely we have a finite automata. Am I right?
Yes.
It is a string, single string. So as it is a single string, definitely we have a finite automata. We know that. Then actually what would be my finite automata? Union of all this. Very naive way to find out finite automata. But it is very important. It says if the language is finite, definitely it is regular. How about if the language is infinite? If the language is infinite, what would be the conclusion? Is the regular language regular or not? Anybody?
So in that case, we'll have to check if any finite automata can represent
Okay.
the language.
Okay, fine. So might be regular, might not be regular. Okay. So how can you be sure that it is regular? And how can you be sure it is not regular?
So if one of the string is not in the language, then it will not be regular.
One of the string not in the language, then it is not regular. Means?
If a finite automata can't represent a language.
Simple. Answer is simple. If you can convert a regular language to finite automata, then definitely it is a, let's say this way, if you can convert a language to finite automata, definitely it is regular. Am I right? Because we have already proven each regular language has an equivalent finite automata. Am I right?
Yes, sir.
So whenever we can convert any language to finite automata, we are pretty sure. If we convert any language to finite automata, definitely it is regular. But what if we don't know how to convert it to finite automata? Then how can you assure it is regular? Guys,
Finite automata equivalent to regex, then
so
regex
the question is
equivalent
there any
to rest.
procedure? Is there any procedure to test regularity of a? The question is yes and no, both. So partially there is a procedure. The problem with the procedure is it is a negative test. The test is a negative. It's a negative test. And the test is called pumping lemma. Test is called pumping lemma. Pumping lemma is a for, let's say this da. Do you know what is meaning by negativity test? Do you have any idea? Do you have any idea about negativity test?
So it will only tell about the negative part, whether a language is not regular or not.
Yes. So pumping lemma is like this. If passes, alas, we don't know. We don't know what is the answer. If fails, we know not regular. Did you understand? If passes, we don't know. If fails, we know not regular. So that's why it's a negative test. Did you get it? Did you get it or not?
Yes, sir.
Okay. So if you understand, so what is actually pumping lemma? What it tries to find? So let's consider this one. Assume we are trying to find out a language, a infinite language is regular or not. What would be the inside language? How many strings are there?
Infinite.
Infinite. And what is the maximum length of the string?
Also infinite.
Infinite strings and max length of a string is also infinite. Good. Now, what is the definition of finite automata? What is the definition of finite automata?
Number of strings or finite. Yeah, state.
Number of states are finite. Now, if we want to accept infinite length string using finite states, then how can you do that? want to accept infinite length string as a finite strings. How can you do that? Tell me.
Sir, আমরা তো loop করি sir every time.
Wonderful. Terminal loop. I need a loop. I need a loop because if there are this number of states, then what happens? If there is no loop, then what happens? For 0 length, you are here. For 1 length, you have to go here. For 2 length, you have to go here. For 3 length, you have to go here. But the string length is infinite. So definitely there must have a loop somewhere. Am I right or no? Otherwise, you cannot accept. Otherwise, you cannot accept a infinite length string. Is it clear to you guys?
Yes, sir.
So definitely there is a loop. Otherwise, not possible to accept infinite length string using finite. Do you agree with me or not, guys?
Yes.
So we are trying, assume we are trying to find out an infinite language is regular or not. So language is infinite. There are infinite strings. It means maximum length of the string would be infinite. Definition of finite mathematics is number of states are finite. Want to accept infinite length string using finite states. So what happened? Let's say we start from here. If there is no loop here, we have to go next state. If there is no loop here, we have to go next state. As the number of states are finite, after some states, visiting some state, either you have a loop or you have to go to new state. But you don't have any more states, so you have to loop. Do you agree with me or not?
Yes.
And
Yes, sir.
pumping lemma is trying to find out this loop. So the catch is pumping lemma pumping lemma, the pumping lemma.
এক্সকিউজ মি স্যার
Yes.
স্যার আমি আজকে ক্লাসটা করতে পারবো না, খালা অসুস্থ তো তো হসপিটালে এখন যেতে হবে।
Leave.
ওকে, থ্যাংক ইউ স্যার।
The pumping lemma is trying to find out this loop. But my question is, if I can find out there is a loop in a language, is it enough to say that language is regular? Did you get the point?
Again,
If I can find a loop, is it enough to say the language is regular?
Still, sir, there could be some strings fall in the loop. তখন
Can you give me a concrete example?
যদি যে prime number a to the power p
So how can you join that one actually? How can you join with that one? That I have loop, still the language is not regular. How can you join that one? So let's take this one. One. So let's take this language. So this is something like this. Definitely it has a loop, and we can find the loop using pumping lemma. Okay, fine, wonderful. we are very happy. We are very happy. Hey, we find a find a loop, so it might be regular. But what happens if this language has two parts? This is part one. For part one, we find a loop using pumping lemma, but it has union to a to the power p, whatever he says, p is a prime. Then what happened? What happened? We don't consider this part. We don't consider this part. That means we neglect this part. For part one, it is fine. It is regular. We get a loop. But for part two, we neglect. Then what happens? Ultimately, the whole thing is not regular. Am I right or not? Because it has a part which is not regular. You cannot express the whole thing as a regular line, a finite automata. Do you agree with me or not? The whole thing is not regular. So we are very sad. So this is the case for passing. If pumping lemma passes, still there might have some part or some string for which we cannot find the finite automata. So that's a passing passing pumping lemma does not guarantee the language is regular. An example is this. Do you agree with me or not? Do you agree with me or not?
Yes, sir.
Now what happens if my language is only this? A P is a prime. Then you run pumping lemma. You run pumping lemma. The pumping lemma. You run this language. Then what happens? It fails. It fails. Then you are very sad, but you are sure it is not regular. Because it fails. It does not have any loop. Does not have. Did you get it? Huh?
Yes, sir.
So pass করলে বলা যাবে না, রেগুলার হতেও পারে নাও হতে পারে, and there might have some extension part, but if it fails we are pretty sure not regular. But pass we don't. Do you have any question? You can tell me. If you have any question you can ask me. Then now the $1,000,000 question, $1,000,000,000 question. What is actually a pumping lemma? How can you define pumping lemma? The pumping lemma. Definition. How can you define pumping lemma? Tell me. How can you define pumping lemma? Assume L is a regular language and n greater or equal to 1. W is a string. W belongs to language and cardinality of W greater or equal to n. If we express W equal to xy G, where xy cardinality smaller than or equal to n, and y is not epsilon, then x, y, I, z belongs to L for I greater or equal to z. Did you understand the pumping lemma? Here it is pumping. Here it is pumping. If you're repeating, that means xz belongs to language, xyz belongs to language, xyyz belongs to language, x double triple yz belongs to language, so on. So no matter how many times we are going to pump y, it is going to be inside the language. Now tell me, what is actually y? Y is what? What do you understand? Which part of the finite automata is y? Yes, no. Which part of the finite automata is y? Something is repeating. So which part of the finite automata is repeating? Assume a finite automata like this. And it can accept a infinite language. So which part is repeating?
Sir, why?
Y is repeating. In finite automata, which part is repeating? This is inside the language. Y is inside the language. But finite automata, which part is repeating? Uh-huh. Sometimes I'm thinking, am I alien or you people are alien? That is the big question. Which part is repeating here? The loop part, this part, loop. And this is nothing but what? Do you agree with me or not?
जी सर.
Because this is y, this is x, this is z. So x, here to here, then z. So if you don't go back once, it is nothing but xz. Then if you follow this one, this is xyz. If you follow twice, it is x double yz. So on. This is a continuum. Do you agree with me or not? Huh?
Yes, sir.
So
जी सर.
this is the pumping lemma. You are trying to find out the loop. So how can you prove this pumping lemma? How can you prove pumping lemma is correct? How can you prove pumping lemma is correct? Let's try to prove this. Proof of the pumping lemma. How can you prove this? What is the length of W? Let's assume W is nothing but the coordinate of W is n. W is nothing but W1, W2 up to Wn. So the
सर
total
greater than equal
transition,
to n বলেছিলাম.
assume assume at least, so nothing is breaking, right?
Yes, sir.
Greater or equal to n, আমি n ধরলাম. The total transition would be like this. Total transition would be like this. So Q0, W1, W2, dot dot dot, Wn. After step 1, Q1, W2, W3, dot dot dot, Wn, so on. এভাবে হতে হতে ট্রানজিশন হতে হতে ফাইনালি কি হবে? Q1 MT epsilon. Okay. Okay, so this is the total transition. All right. এখন Q0 to Q1 up to Qn. How many transitions are there? How many states are there? How many states are there? How many states are there?
So one state.
One state. Each one is state. Q0 is a state. Q1 is a state. So how many states?
N plus one.
N states.
N
তাহলে
plus-
n
N states. Good. N states না n plus 1 state. 0 আছে.
0 থেকে sorry sir.
N plus 1 states. এখন assume number of states equal to n. Number of states equal to n. ধরে নিলাম। এখন আমার নাম্বার অফ স্টেটস হচ্ছে n আর আমার টোটাল স্টেট এখানে এসেছে n plus 1. So what can we conclude? What can we conclude? In the finite automata, I have n state, but actually after traversing, we get n plus 1 states. So what can we conclude? According to Pigeonhole Principle, according to Pigeonhole Principle, once at least one state repeats. One state repeats. তাহলে আমরা এখন x ধরলাম. We assume x is nothing but W1, W2, dot dot dot. Let's say W I. Y is nothing but I minus y is nothing but Wi
So Wn দিয়ে দেন স্যার বেটার হয়।
Wi plus 1 dot 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 Wj, and G is nothing but Wg plus 1 Wg plus 2 dot 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 Wl. So this is the case. Okay, so this one is repeated. So if this one is repeating, xj should belongs to language, xyz should belongs to language, xyyg should belongs to language. This means if you continue, x, yi, z belongs to language, where I represent. Okay guys, so this is the proof of pumping. Done. এখন বলতে পারেন যে স্যার এটার কাজটা কি? How can I do anything? See.
স্যার পিজিয়নহোল প্রিন্সিপালের জন্য আমরা কি বলতে পারছি তাহলে একটা লুপ অবশ্যই আছে এর মধ্যে এরকম তো?
হ্যাঁ আছে, কারণ here there are number of states is n plus 1, But in the finite automata, I have states and so at least one should repeat according to Pigeonhole Principle.
বুঝতে
Here
পারছি
we have n plus 1. Here I have n. At least one is repeated. Oh, there is a tiny part. And definitely, I is smaller than G. G appears later than I. So, Y is not E. That is also correct. Now, how can I act with pumping? How can I act with pumping? Prove that regular or not. How can I prove this? Prove that L equal to AN, BN, and greater equal to 1 is regular or not. How can I prove that? We are trying to fail the pumping lemma. How can I fail the pumping lemma? What should be my X? What should be my Y? What should be my Z? What should be my X? What should be my Y? What should be my Z?
স্যার এক্স এ ওয়াই বি
X A Y B. X যদি A হয়, Y যদি B হয়, আর Z কি হবে? W is this. W is A N B N. Then what would be X? What would be Y? What would be Z?
So sir, x will be 8 to the power n, and z will be b to the power n, and y will be repeating part, loop part.
Why would be repeating part? What would be the repeating part? What would be the repeating part? How about this? A equal to n minus I, Y equal to I, Z equal to Bn. Is it clear? We assume this. Assume W equal to An, Bn, X equal to A n minus I, Y equal to Ai, Z equal to Bn. Then what happened? See, what is the first criteria? The first criteria is, what is the first criteria for pumping lemma? N should be greater or equal to 1. It is fine. W is a string belongs to, and W should be greater or equal to N. That is also fine. W to X, Y, G, where X, Y should be smaller or equal to N. Should be smaller or equal to N. So X, Y mod is nothing but A N I, AI, which is nothing but N. But what is W here? W is twice N. It is smaller or equal to twice N. So done. So according to, and Y is not, we have to also make Y is not equal to E. How can we make Y is not equal to E? How can we make Y is not equal to E? How can we make Y is not equal to E? How can I make this thing? By making I greater or equal to 1. Now, according to pumping lemma, according to the pumping lemma, X, Y, I, Z belongs to language for I greater or equal to 0. Now if we place I equal to 0, what do we get? We get xz belongs to language, which is nothing but a n minus I, b n belongs to language. But n minus I not equal to n for এটা আসলে এইভাবে করাটা আসলে বোকামি, এটা এইভাবে না, let's not do this. হ্যাঁ, according to this, okay. Let's now if we place I equal to 2, let's say I equal to 1, then what do we get? X, Y, Z belongs to language, which is nothing but now if we place I equal to 0, then X, Z belongs to language, which is nothing but A n minus I, B n belongs to language. But n minus I not equal to n, hence the pumping lemma is Q8. Did you get the point? Is there any question you can ask? Guys, do you have any query? You can ask.
No query. Please skip this part.
Please keep this.
এই পার্টটা স্কিপ করেন স্যার, সামনের পার্টে চলেন স্যার।
কেন সমস্যা কোথায়?
না স্যার, বুঝছি স্যার,
গুড, তাহলে আমরা আরো
গোলটা বুঝছি স্যার।
so next example যাই। The main thing is we are trying to find out a loop. Find out a loop whether that is viable or not. So let's do this one. Prove that a to the power p is a prime. Is not regular. How can I prove that? Prove that p is a prime is not regular. How can we prove that? How can you prove that it is not regular? Hmm? How can you prove that? How can I prove that it is regular? Again, let's divide. Let's assume W belongs to language. W equal to x, y, z. X equal to
a to the power 3 minus I.
u, y equal to a to the power v, z equal to w. Okay. And what are the constraints? U, v should be greater or equal to 1. So this is the only one constant. So that y is not equal to u. Because v is equal to যদি ইয়া হয়ে যায় 0 হয়, then it would become epsilon. Alright. Then what is the catch? So this is nothing but a u a v a w according to the pumping lemma. According to pumping lemma, x, y, I, z also belongs to language. It means AU, AVI, AW belongs to language. It means what? It means AU, VI, W belongs to language. So finally it means U, VI, W is equal to P prime for any values I greater or equal to 0. you have to break this. How can we break this? How can we break this? Let's consider I equal to u plus twice v plus w plus 2. And definitely as v greater or equal to 1, I would be greater or equal to 0. So no problem. Now what is this? If we put I equal to u plus twice v plus w plus 2 over there, what do we get? U plus v, u plus twice v plus w plus 2 plus w. What is this? U plus uv plus 2v square vw plus twice v plus w. What is this? Let's take this uv plus 2v square plus vw, and also take u plus twice v plus w. So let's consider this and consider this. What is this? Take common v, u plus twice v plus w, u plus twice v plus w. What is this? It's nothing but u plus twice v plus w into v plus 1. Now, 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 this one should be prime. Is it really prime? Is it really prime? Is it really prime? No, it is not prime, because multiplication of two natural numbers. So done, UET. So it is not regular. Do you understand the solution? Do you understand the solution or not? হ্যাঁ কথা
জি
বলো।
স্যার।
ওকে, আরেকটা কি করবো এটা?
শিওর স্যার।
করবো স্যার? ওকে স্যার। আপনারা কি করছেন? What you people are doing? What you
স্যার নোট
people are,
করছি।
আপনারা করছেন?
তো আজকে বেশি করেন, আজকে দেখা যাচ্ছে না।
এখন হঠাৎ করে কিছুই দেখা যাচ্ছে না বা?
না 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 স্যার, আজকে ফার্স্ট থেকে দেখা যাচ্ছে না। আমার মানে আমার নেট স্লো, বা আমি ওই মোবাইলটা দিয়ে একটু তো আজকে, তো আমার ওয়াইফাই কানেকশন নাই, তাই
ও
ফার্স্ট থেকে দেখতে
আচ্ছা
পাচ্ছি না।
আচ্ছা, এটা খুব মজার। এটা খুব মজার। আমরা তো we have already proved a and bn is actually not regular, right? A and bn and greater or equal to 1 is not regular. How about this? Let's say this one. Having equal number of A and number of B is not regular. How can you prove this? How can you prove this? How can you prove this? Equal number of A and number of B. Language of all strings of equal number of A and equal number of B. How can you prove this is not regular? How can you do that?
Same case of previous a to the power n and b to the power n. There is contained, but here is a union b.
কিভাবে এটা করা যায়? আচ্ছা, এটা A star B star, is it regular? Is it regular? A star B star.
জি স্যার।
What would be the finite automata?
স্যার একটা স্টেটে এ আর বি একটা লুপ চলবে।
Fantastic. খুব ভালো, বুদ্ধিমান, খুব মেধাবী ছেলে।
থ্যাংক ইউ স্যার।
Very talented person. আচ্ছা, very talented. No, I really appreciate you. Very talented. তাহলে it is regular. Fine. It is regular. মনে করেন মানে L dash হচ্ছে my L dash is A and B and vector equal to 1. Do you agree with me? This is my language. And is it regular? Is it regular?
No, sir, this is not regular.
It is not regular. Now, L dash intersection A star B star. L dash intersection A star B star. What is this? What is this to? No, এটা করো। L intersection A star B star. What is this?
Sir, L is
It is nothing but L dash.
here.
It is nothing but L dash. Karon, what is L? Having equal number of A or B. So it is actually ensuring equal number of A and B. And this one is ensuring no A comes after B. Then what happens? Ultimately, it would become AN, BN, and greater equal to 1. Now, is this regular? Not regular. Now, this one is regular. If this one is also regular, we know that from our very basic theorems that whenever two languages are regular, their intersection is also regular. So if L becomes regular, this one is already regular. If this one becomes regular, both of the intersection also becomes regular. That means L dash also become regular. But we know that L dash is not regular, so definitely it is not regular. Okay, guys. So this is the proof. Did you get it? Did you buy it? Did you buy it or not?
Yes, sir.
Okay, sir. তাহলে আমরা কয়েকটা এক্সাম্পলে যাই। এক্সাম্পল পরে আজকে আমরা চলে যাব। Let's talk about this. Is it regular or not?
Yes, sir, regular.
Why it is regular? Why it is regular? We can draw finite automata. That's why it is regular. How about this? Is it regular? Is it regular or not? Number of A is even. Simple.
Yes, sir. We can draw finite automata.
We can draw finite automata. 1, 2, come back. 3, 4. 1, 2. Oh, 1, 2, 3, 4. So this is the regular. It is regular. Good. How about this? Is it regular?
Yes, sir. Odd.
It is also regular. So what I'm going to do? What I'm going to do? How can I get the odd? How can I get the what? Simple. এখানে আমি লিখতে হবে 1, 2, 3, right? All right. How about this? Hyphen plus 2 and get equal to 1. Is it regular? Is it regular or not? What are the strings inside this language?
So 2 is, 5 is.
A5, then
A8, sir.
A8, then
A11,
A11, then
14, 17, 20.
14, 17. Good. Is it regular or not? Is it regular or not?
Sir, regular, sir.
Why it is regular?
Because we can draw finite.
We can draw finite automata.
Finite
So
automata.
what is the logic behind drawing the finite automata?
It's up to 3
Pattern.
It's a pattern. Good, very good. It's a pattern. But what type of pattern is this?
Increases by same A cube.
It is called arithmetic progression.
Yes, sir.
Arithmetic progression. That means the difference between successive terms are same. So 8 minus 5 is 3. 11 minus 8 is 3. 14 minus 11 is 3. So these are called arithmetic progression. Whenever we have string of arithmetic progression, definitely we can actually have finite automata. What is the reason behind that one? What is the reason behind that one?
Patterns.
Yes. So if this difference is my loop, the difference is my loop, our loop. So definitely we can generate 5, then we can generate 8, then we can generate 11, then we can generate 14, then we can generate 17. If difference is our loop, that means 3 plus 3, definitely we can generate this arithmetic progression. That's why whenever arithmetic progressions are there, it is always finite automata and regular language. How about this? A to the power 2 to the power n and get rid of it. Is it finite automata? Is it finite automata? A, 2, and get rid of 1.
No, so it was GP হয়ে যেতেছে. So maybe not regular.
Good. So it is not arithmetic progression. It is become GP, geometric progression. A geometric progression is different. You might argue যে স্যার এখানেও যদি লুপটা থাকে, এখন প্রবলেমটা হচ্ছে কি এটা কি এরকম, এটা হচ্ছে A2, then A4, then A8, then A16. The problem is difference. The expression is 2, 4, 8, 16. This is a content. At first difference is 2, then difference is 4, then difference is 8. It is increasing. So you cannot create a loop which always going to have, you cannot create a loop which always have this difference. Because the difference is increasing. You always have this difference, 2 or 4 or 8. But what happened next time it increased more. So you cannot actually cover that difference using this kind of looping. So that's why it is not regular language. It is regular language. It's regular language. It's regular language. Good.
লিনিয়ার
এবার
হবে এরকম কিছু স্যার।
linear. Arithmetic progression is linear.
লিনিয়ার।
Definitely. But it is not linear. That's why we can't.
জি
Number
স্যার।
6. How about this? Palindromes. Palindromes. Is it actually regular or not? So W, WR. W, WR, where W length is greater or equal to 1. Is it actually regular or not?
Not regular. So,
It is not regular. Why it is not regular?
so W can be infinite length. Then we have to compare the reverse.
Wonderful. So what is the example of palindrome? Let's assume my W is W equal to ABB and my WR is equal to BBA. So what is WR? It is nothing but ABB, BBA. So I have to compare this with this, this with this, and this with this. So if I want to compare like this way, I have to remember ABB. ABB. Now my length is actually infinite. So it might be grow infinitely. So I have to take care of infinite length W, and we have to remember each of the instance of W. So we require infinite number of states, which is not possible. That's why it is not regular. Wonderful. How about this?
So W bounded থাকলে তো it would be regular, right?
অবশ্যই কারণ তাহলে তো ল্যাঙ্গুয়েজটাই ফাইনাইট হয়ে গেল, তাই না?
Yes.
ল্যাঙ্গুয়েজটাই ফাইনাইট হয়ে গেল। যেমন মনে করেন আমি দিলাম এটা 7. Let's do this. 7. How about this? WWR W, let's say, equal to 2. Then what happens? This language is finite because it means we have AA, AB, BA, BA, AB, BB, BB, anything else? No, nothing. So these are, we have only these 4 strings. So definitely this language is regular. Acha. Whenever number of strings are finite, definitely it is regular. Okay. How about this? This is very interesting. W, X, WR, W, X belongs to alphabet plus. Is it regular or not? Is it regular or not? Did you understand the language?
No, sir. Language স্যার একবার একটু বলবেন।
স্যার ল্যাঙ্গুয়েজটা বুঝিনি স্যার।
মনে করেন sigma is a comma b, then W and X should be at least 1 character, but there is no bound. W can be infinite, X can be infinite. So let's assume W is AB, X is BB, তাহলে WR is equal to BA, তাহলে WX, WR is what? AB, BB, BA. Is this kind of language is regular or not?
No, sir. Again, we have to compare W and WR.
Think carefully. How about this? Same thing. This is my string. Am I right? This is my string. Am I right? Instead of considering X equal to BB, if I consider W equal to A, X is equal to BB, and W are equal to A. Is there any problem? Is there any problem?
No, sir.
Then what happens? If I can check just the first one and the last one, and middle can be anywhere, definitely I should be inside this language. Am I right or not? Am I right or not? So what would be the regex for this? The regex would be like this. A union B star, A or B, A union B star, B. It has a regex. So definitely this language is regular. You agree with me or not? It's a little bit complicated, but it is regular. Do you agree with me or not?
Sir, এখানে W লেন্থটা কি স্যার বাউন্ডেড?
কারণ length bounded না, X এর না W এর না, but their length should be at least 1. Nobody is bounded.
So W can be infinite, right?
W can be infinite, X could be infinite. That's why X eta. So this is my string. X is eta everything in the middle except first and last character. Did you understand?
Oh, okay, sir.
Then what happened? Definitely the first and last character should be same. So it is better to check whether first and last character is A or not, or whether to check first and last character is B or not.
Yeah, sir.
That is fine. So that is the regex. A and A, first and last is A, middle can be anything. B or B, middle can be anything. So definitely this is regular. Am I right?
Yes.
So let's move to next round. How about this? L is WX, WR, where W belongs to sigma plus and length of X should be 5. Is it regular or not? Is it regular or not? Now X cannot be infinite. X has highest length, S has length of 5. That's the smaller record. Is it regular or not? Yes, no? Just tell me. Is it regular or not?
Sir,
Now
not,
what happened?
not
It is
regular.
not regular because now X cannot
Now
eat everything.
So now
Now
W.
X cannot eat everything. For example, say my W is, let's say, A B B B. X is equal to A B A B, and W are equal to B B B A. Then what happened? W X W R, which is nothing but A B B B A B A B B B B A. Now what happened? If you can change even X, you can eat up to this. You can either eat up to this or you can eat up to this. Okay. So what happens? Still you have to check lot of more things. You cannot check only first and last. You have to check more. So that's why this language is not level. Okay, guys? Should we stop here today?
এটা আরেকবার স্যার এটা
So you cannot eat up. So last case, the previous one is regular because using X, you can eat everything except first and last. But as we have bounded the length of the X, right now you cannot eat everything except first and last. You have to stop after eating 5 lengths. So still you have to check lot more things. And that checking is infinite. So that's why it is not regular. Did you get it?
জি স্যার বুঝতে পারছি
Okay, sir. So we should stop here today. Just take your attendance.